coming.
He said you weren't gonna be here at all.
Well, he doesn't miss it.
I'm just saying that he just said you weren't here at all.
No.
Okay? If we're gonna talk about that, one standard deviation, which means that I take the standard deviation and add it to the mean, right? Remember that circle with a little line on it meant standard deviation, right? Well, can't it also be subtracted from the mean? So I have a plus standard deviation and a minus standard deviation, right? And I can do that again and have two standard deviations, two standard deviations. You see what I'm doing so far? I'm just taking and adding standard deviations to the mean. Three standard deviations on each side, and four standard deviations. This almost looks symmetrical, doesn't it? Doesn't it look like I could take this half and fold it over on top of this half?
Mm-hmm.
Well, if I kind of connected the endpoints here, I have something that looks like an upside down bell, don't I? Or a bell, hence the name bell-shaped curve. It's also called a normal curve. Just by adding standard deviations to the mean. So essentially, standard deviations take my mean and take the whole data that is there and separates it into 8 different areas. 4 that are positive, or an increase to the mean, and 4 that are smaller or a decrease to the mean. Does that make sense? Okay? An interesting thing happens with that bell-shaped curve, and this remains constant with all bell-shaped curves. So if I have my bell-shaped curve, and my mean is right here, sometimes it's easier to draw a bell than other times. One standard deviation, which came out to here and to here. Okay? That whole area under that curve, if we were talking about that, has a certain percentage associated with it. 34% above the mean, 34% below the mean, which meant, you know, as I did that plus or minus 1 standard deviation and everything was symmetrical, so shouldn't I have the same percent to the right as I do to the left? Okay? Then I can go out 2 standard deviations. Well, there's a certain percentage associated with that area too that increases it. It is 13.5%, 13.5%.
Is the one on the left though marked negative?
Not in percentage, but the standard deviation is. Okay? But they're talking basically about this area right here is 13.5% of that whole curve. Okay? This area right here, all of this would be 34% of everything. Okay? 3 standard deviations. Well, it doesn't look like if I drew this line, I'm going to have a whole lot of area left, am I? Right? It's going to get smaller. Well, this area right here is 2%. 4 standard deviations, which basically is this line that comes out this way and this way, ends up being 0.5%. You need to have those numbers written down and or memorized. So I'll give you a little bit of time. Okay. How many people score greater than 72 and less than 80? Okay. If I looked at the chart that I have here, Jagger is right. 72 starts at 1 standard deviation below the mean, doesn't it? So I have this percentage, so I'd have 34 plus 34. 13.5 takes me out to 78, doesn't it?
Yeah.
But I want less than 80, so that means I also have this section. Right? So that's 68, that would be 70, plus 13.5 would give you about 83.5%. So I take 0.835 times 1,000. So about 835 people would score less than 80%. Okay? Remember when I set it up here to a grading scale?
Yeah.
Okay. How many people would get an A? How many people would get an A according to this?
Oh, 50.
An A. An A would include these two, which would be 2.5% times 1,000. So that'd be 0.025 times 1,000. Correct? And what's 0.025 times 1,000?
25. What, Jared?
I don't know how you got 50.
You said 250.
Oh. Okay? Only 25 people out of those 1,000 would get an A if I used a normal curve. Can I understand it?
Mr. Horman, what would happen if everybody had the same score? Is it still gonna come out that 25 get A's and 25 get F's?
If everybody had exactly the same
Yeah.
score, they would probably all get a C.
So that'd be the mean, and no deviation?
Yep. There would be no deviation, so they'd all get a C if they graded on a strict normal curve. So is normal curve a fair way of doing it? No, not really, but it is done.
Like at colleges?
Yeah. Not as much as it used to be. But in some of those where they had 300 or 400 people in a class, they compared everybody to...
Would that take more work than just giving them 0%?
But the only fair way is you're comparing everybody in that class to everybody else. Is part of the reasoning behind doing it that way. You're comparing everybody to everybody.